This is number 20 and 21 on the exam 3 review. So we're asked to evaluate some logs, find the value of x. So I'm going to start with changing them to exponent form. So if I take a, that's going to be 9 raised to the power of x equals 3. So my problem is x is an exponent, so it's a little bit harder to get to. So what I want to try to do, if I can, is see if I can get a common base. Alright, so I look at my bigger number 9, and I'm thinking I can write 9 as 3 squared. Okay, so I'm going to replace 9 with 3 squared, and then make sure to keep that x. So now I have the same base, so I got it a little bit closer. Now remember over here, this is just 3 to the first. So I get 3 to the 2x, when I multiply my exponents, is equal to 3 to the 1. Once my bases match, I can drop my bases and set my exponents equal to each other. So I get 2x equals 1, or x equals 1/2. Alright, so let's try the same thing with b. I start with changing it to exponent form, and I get 8 raised to the negative 2 equals x. Now this one, x is not an exponent, so really I just need to simplify the left-hand side. That's 1 over 8 squared, which gives me x to be 1 over 64. Now we do have some restrictions on these, which I probably should have mentioned. Anything on the log side has to be positive. Anything on the other side, it really doesn't matter. It can be anything. So since my x was on the left on that one, I do have to check and make sure that it's positive, and it is, so I get to keep it. All right, so let's go back to C. We want to start by changing it to exponent form. So we get 36 to the x equals 1 over 6. Alright, so I want to try to get a common base. Now I know that 36 is 6 squared, but that's still raised to a power of x. Now if I think about 1 over 6, I would prefer that 6 not to be in the denominator. So in the denominator it's 6 to the negative 1. I mean 6 to the positive 1. So if I move it to the numerator, it will become 6 to the negative 1. Alright, so if I clean that up a little bit, I get 6 to the 2x equals 6 to the negative 1. Once my bases match, I can set those exponents equal to each other. I get 2x equals negative 1, x equals negative 1/2. Now that was negative, so if I go over and look, my x is over here. Okay, on the right side it can be anything I want. It's only on the log side that it has to be positive. Alright, so here's the last one. This one ends up actually being the easiest. When I change it to exponent form, I get x raised to the 3rd power equals 5 raised to the 3rd power. Now I don't have matching bases, but I do have matching exponents. And what that means is my bases have to be the same, so I know that x has to be 5. Alright, so now let's look at 21. Sometimes people don't like these because there's not enough stuff written. They want something in all 3 places. So I could take a and I could rewrite it. So first of all, if I don't see a base, I know it's a 10. So I'm going to go ahead and write a 10 in there. And if I want to evaluate it, if you want, you can just set it equal to x. Alright, so then when I go to exponent form, I get 10 to the x equals 10,000. Alright, so I'm back to trying to get a common base. So 10,000, notice it has 1, 2, 3, 4 zeros, so that's 10 to the 4th. So once I have a common base, then my exponents have to match, so x is going to be 4. Alright, so if I evaluate log of 10,000, I should get 4. Alright, so let's do the same thing with this one. I'm going to save myself some time. I'm going to put the 10 there, and I'm just going to go ahead and set it equal to x. So if you don't see a base for a log, it is a 10. So when I go to exponent form, that would be 10 to the x equals 0.001. Alright, so we're going to do a little place value rethinking. This is the tenths, hundredths, thousandths. So I could rewrite this as 1 over 1,000. All right, so that would be 1 over 10 to the third, since there's 3 zeros. And trying to get that common base, if I move that 10 up to the numerator, that's going to make that exponent negative. So now I can set those equal to each other, and I would get -3. All right, now the last two, these are kind of, well, this one's a different one because it's in exponent form. So I want to rewrite it this way. I know if I have a natural log, I know that that's base e. So you can put log base e, or you can put ln base e. And I want to know what that's equal to. All right, so there's a little shortcut to these. If these numbers match, then these numbers match. So that means that x has to be 5. All right, so if we go to the last one, I have ln of e to the third. So remember, ln just means log base e. So you can write it this way, or you can write it how I did in the previous problem, of e to the third. And I want to know what that's equal to. So I'm going to put it equal to x for now. All right, so then when I go to exponent form, I get e raised to the x equals e raised to the third. Well, these are nice. I've already got a common base. Therefore, x must be 3.